Hello, this is Earth Science teacher Tim Martin, and welcome to my series of videos of Earth Science. In this brief video, I want to give you an introduction to Earth and the Earth as a planet. In Earth Science, there are various domains of study, and many of them contain the word sphere. There's the atmosphere, the hydrosphere, the geosphere, magnetosphere, and so on. Let's take a look at some of these and how they relate to our planet. One of my favorite all-time images of our planet comes from back in 2003 when Hurricane Isabel was bearing down on the east coast of the United States. You may recognize the Bahamas and Florida towards the top of the image. Along the coast you may see the Chesapeake Bay, and on the far right-hand side you may notice Long Island with New York City. Those of you who are my students in Greensboro, North Carolina, yes, we're on this picture too. But what I'm especially interested in is this thin blue line. That's the Earth's atmosphere. The Earth's atmosphere is the gases that surround our planet, and they're remarkably thin. Nearly 100 kilometers or only 60 miles of atmosphere is what protects the surface from the vacuum of space. In terms of the composition, the Earth's atmosphere is mostly made out of nitrogen gas at 78%. We have a significant amount of oxygen, approximately 21%, and also a small amount of argon in our atmosphere. It's also worth noting there are some other trace gases, such as CO2 and water vapor, that are also very significant to the makeup of Earth's atmosphere. As far as the next sphere I'd like to talk about, let's imagine a brief thought experiment. Imagine you are from another planet designing a spacecraft to land on Earth. What would your spacecraft look like? Well, I hope it would float. This is one of my best pictures that's an example of what the surface of planet Earth looks like. Another time, I got a representative picture of planet Earth. It looked like this. Well, actually, this one's pretty rare. That's the fluke or tail of a humpback whale. On rare occasion, a view of planet Earth may involve some rocky outcrops, islands. But the vast majority of places where you go on planet Earth, it looks something like this. An expansive blue with a perfectly flat horizon. This, of course, is the hydrosphere, all of the water on our planet. Our planet is referred to as a water planet because 71% of the Earth's surface is covered by water. Much of that water is in the oceans, some 97%, which only leaves 3% as fresh water. But don't think that that's all located in rivers and lakes and streams, because the vast majority of our fresh water is what is locked up in the cryosphere, or the ice on the planet. This image on the left is the southern end of the Greenland ice sheet as viewed from an airplane. Greenland contains 10% of the ice on the planet, while 90% is down in the Antarctic ice sheet. The images on the right are from Vatnajökull in Iceland. These are parts of the third largest piece of ice on the planet. The geosphere, or sometimes referred to the lithosphere, is all of the rocks and soil on the planet, the most common materials that make up the hard part of planet Earth. Of the rocks, it's worth noting there are two basic different types of crustal rocks. The continental crust, which is mostly made out of the rocks such as granite, and oceanic crust, which is mostly made out of rocks like basalt. But rocks and soil, or sediment, are what compose most of the geosphere or lithosphere that we can interact with. But let's take a look a little deeper into the Earth. Imagine we could cut the Earth apart and we'd see layers. Many of you are familiar with the three-layer model of the Earth, where we have the crust, the mantle, and the core. In this class, we'll explore that a little more deeply. Below the crust is the area we refer to as the lithosphere, although the lithosphere also includes the crust. Below the lithosphere is the asthenosphere and the mesosphere. The core is also subdivided into the outer core and inner core. In terms of their composition, the crust is made out of rocky material. The upper mantle and crust, the lithosphere, is made out of rigid rock that progressively gets hotter. The asthenosphere is a putty-like, thick, semi-liquid material, as is the mesosphere. The outer core of the Earth is made out of convecting liquid metal, and the inner core, due to the great pressures inside the Earth, is solid metal, mostly composed of nickel and iron. You may ask how we know the interior of the Earth when humans have never gotten a probe deeper inside the Earth. In fact, the deepest humans have ever penetrated the Earth is at Kola Superdeep borehole in Russia that's 12 kilometers or approximately 7.6 miles deep. So how do we know the internal structure of the Earth? Well, vibrations caused by earthquakes or seismic waves have been used to determine the structure of the inside of the Earth. There are primary waves and secondary waves that are generated when an earthquake happens. The earthquake vibrations shake the Earth. Some waves travel the whole way through, while others seem to be blocked. The P waves, represented in brown, go all the way through the Earth. The secondary waves, represented in white, have shadow zones. There are areas on the opposite side of the Earth where these secondary waves do not penetrate. And from here we've used seismic waves to map out the structure of the inside of the Earth. The scientists at the United States Geologic Survey and Woods Hole Oceanographic Institute combined together to provide this diagram that compares the hydrosphere and geosphere. You'll notice by volume, the geosphere is much, much larger than all the water on planet Earth. From this, we can understand that the oceans, although they may be vast in surface area, are very thin in terms of the overall structure of the Earth. Finally, the magnetosphere. The Earth has a powerful magnet. The magnetic field is not completely understood on planet Earth, but we do know it exists. It may be caused by the rotating liquid metal in the outer core of the Earth. We also happen to know that electric currents are important for the cause of magnetic field. So some combination of the rotating and convecting liquid in our core and electrical currents flowing through that liquid are likely the cause of the Earth's magnetic field. One thing we can say for certain is that the magnetic field is much more useful than just for navigation, because the magnetic field protects all the life on planet Earth from harmful radiation from deeper in space. Speaking of life, that brings us to the biosphere. While not technically one of the domains of earth science, the biosphere, all the living creatures in the atmosphere, all the creatures in the hydrosphere and geosphere, depend on these different spheres of earth science for the surface, for their food, for the air to breathe and water to drink. The biosphere is integrally connected with all the other spheres of earth science. Thanks for watching this brief video, and I hope to see you again in several more of the Earth Science video series. Thanks for watching.